Good morning, all. Hope everybody had a great summit. Awesome. It's almost time to go home. But before we do that, we have one more thing to do. We need to talk about supply chains, and we need to talk about knowledge graphs on Snowflake. OK, so my name is Amanpreet Singh, and I'm with Blue Yonder. And I manage Greenfield Innovations. And we've been working on this project with Molam and his team from Relational AI to really bring in knowledge graphs to modernize some of our solutions. And we're going to talk about that. Supply chains became a common household name or word probably because of the pandemic. And we're going to talk about that and what makes supply chains very interesting, the solutions. And then we will talk about the knowledge graphs and how we leverage knowledge graphs to really bring in the capabilities that allow us to look into our networks seamlessly. I have a picture over here of a butterfly flapping its wings, maybe somewhere in Africa. But what does this have to do with what we are doing today, or what does this have to do with supply chains? The power of just a very innocent flapping of wings might not seem to be much, but it actually can cause a lot of disruptions. It can create changes to the weather patterns. It can create more evaporation. Maybe it will not lead to hurricanes, but it can cause significant weather disruptions, right? As a matter of fact, did you know, and I was reading this yesterday, a very profound statement. In the last 12 months, starting from April of 2023 to May of 2024, our Earth has recorded maximum temperatures since the pre-industrial days. And you know by how much? 1.63 degrees Celsius. That is an equivalent of around 3 degrees Fahrenheit change in temperature, in Earth being hotter than ever before. Imagine that for a second. I'll repeat. In the last 12 months, for 12 consecutive months, our Earth has had record temperatures recorded since the pre-industrial days. In fact, last May, the May that just went by, May of 2024, was the hottest recorded May in the history since we have started to measure temperature. Hottest by 1.52 degrees Celsius. What does that do? It has deeper implications on our planet, causing these kind of hurricanes or other weather patterns. We all know about Katrina that caused around $125 billion in damages, around 2,000 fatalities, too many disruptions. Who knows about the Suez Canal, March of 2021, just as you were headed into the pandemic. The ship got stuck. $10 billion a day of supply, $10 billion. Stuck for 6 days, caused massive, massive supply disruptions. And then, of course, the pandemic happened, right? When we talk about disruptions, typically, they are one-dimensional. And what I mean by that is because we are in supply chain, we look at demand and we look at supply. When I have a disruption, a typical disruption will have a disruption on one side of the equation, either on a demand side of the equation or on a supply side of the equation. Meaning one side is always deterministic and one side becomes undeterministic. When COVID happened, and that's why supply chain became a household name, because now we had disruptions happening at both sides, both in demand and in supply. People were working from home. The demand for computer peripherals, cameras, your monitors, laptops, all went up. The customer behavior changed. Nobody was wanting to go into the stores. They all wanted stuff to be shipped to their homes. So the demand patterns completely changed. And it took us, especially from a supply chain solution standpoint, and our customers by surprise. There was one form of disruption. There was another disruption happening at the same time because of COVID. People are not able to show up for work. People are not able to get to the warehouses. They're not able to get to the docks. So now all the supply is getting delayed. And now suddenly we have, in my 30 years of working in supply chain, never had a situation where there was an imbalance in both places. It was the first time that we ever saw that. And here is a chart. I'm not going to walk through all of it, but just a chart showing the amount of supply chain disruption. It's a McKinsey chart, by the way. Amount of supply chain disruptions that have happened since 2000s, all the way up till the 2023. And when you look at the legend, there are these disruptions that have a frequency in years, right? They will have every 2 years a 1 to 2 week disruption, and every 5 years around a 2+ month disruption. What we are saying is that the disruptions and the speed at which that they are happening to us because of whatever we are doing, all the small things that we do, which do not help the environment, by the way, have a profound impact, and especially on supply chains. At the same time, when we look at what has happened in the last 15 to 20 years, ever since the internet came in, we had plethora of technology. We are in an age of robotics. We have data cloud for the last 15 years now. And in the last 10 years, machine learning, artificial intelligence has become main stage, as we all know, to say the least. And what it does for us from a supply chain perspective is creates that opportunity, that perfect opportunity where we can meet these disruptions happening at a very enormous scale, both in demand and supply, to be able to leverage these solutions that are born in the cloud, that leverage AI and ML, and now the large language models, to really cope up with all the variabilities in supply chain and the world that we see. So what are some of the key data-related issues that we see, or when we speak to our customers, what they tell us? There are 5 key causes. These are the 5 key leading causes of why the supply chains are not able to meet the required demands of our customers. There's lack of collaboration 66% of the time. There are data challenges, of course, we all know about that. There are labor shortages, 94%. There's trouble hiring. Even if you can hire, you don't have the right talent. There's market volatility. We just talked about that. And then there is rising costs. And here we are in Blue Yonder, and we've been doing supply chain solutions for the last 38 years, or close to 4 decades. We specialize in AI and ML, and we specialize in bringing best of the breed solvers that are available in our industry, in supply chain domain. How we have grown, we used to be called JDA. If some of you have been around and have been around supply chain, you would have known about JDA. We grew by acquisition. We grew by acquisition of best of the breed solutions. And those best of the breed solutions were Managistics, were I2, and I used to work at I2 back in the day, and so were some of my colleagues over here. And then we bought Red Prairie, or acquired Red Prairie, and then we acquired Blue Yonder. So when we were doing all of this, it was for the best of the breed solutions from Managistics, from I2, or from a warehouse management from Red Prairie, et cetera. And in 2018, we bought Blue Yonder, which we actually took that name as well. And that brought us into industrial scale artificial intelligence and machine learning. Using those solutions today, we actually do 10 billion predictions per day. 10 billion predictions per day, all on the cloud. 2021, we were acquired by Panasonic. And then since then, we've done two major acquisitions of Dawdle and Flexus. And what we are really trying to do is come up with an end-to-end solution in the supply chain domain. And we have one more. We announced this like last month, acquiring One Networks as well for a little less than $1 billion. So in supply chain, Blue Yonder is a dominant player where we are into all aspects of supply chain. Typically, there are 5 pillars when we talk about supply chains. There is sourcing, planning, make, logistics, and then reverse. And we play in all of them. We are the only solution that does end-to-end supply chain, and we do that on the cloud. We are on the Azure platform using Snowflake. So what was this project about? That we embarked on a journey with relational AI on knowledge graphs. So we had a product called Supply Chain Strategist that was actually an I2 product. It was built in the 1990s, early 1990s. And it was written on C++ code, on a Oracle database, and it had not been upgraded for various different reasons. It was still an on-prem. Our customers still use it on-prem. And what was happening was this product was coming into limelight. There was a lot more demand coming for it especially in the last 2 to 3 years, because of all these disruptions that I talked about. And there was a need to modernize that. And we decided to go with the relational AI technology that you all heard about, in the last couple of days during the keynotes as well. So what does it really do? So Supply Chain Strategist, as the name says, it's basically a network optimization tool. What it does is it helps companies make decisions regarding, hey, I need to open up a new warehouse. Where should I open it? So based upon the demand, you feed the demand and your current network to it, and it basically comes up with an optimal way of where I should be really putting a new warehouse, taking into consideration certain objective functions. Okay? And those objective functions could be costs, and I can actually model both fixed costs and variable costs. Or it could be that my objective function is to maximize my demand. And now we are introducing a third objective function, which is sustainability. Right? So how do I do that, keeping my business objectives and drive the right solution for my customers? Right? So those are kind of the decisions that this tool makes. And this tool is very, very helpful. I can run it on a weekly basis. I can run it on a monthly basis. I can run it on a quarterly basis, depending upon how I really want to redistribute or replan my network. Right? And as the pandemic was occurring, there were a lot of these decisions that were being made, especially by the grocery retailers or other retailers, where I have my DC outside of the city. Should I put satellite DCs, which are like smaller DCs, 10,000 square foot or around that much? Should I be putting them within the city? Then where? And how many? And how will it help me with the same-day shipment and same-day delivery to my customers? How do I prioritize that? So those are some of the decisions that are driven by this tool. And like we said, we are on Snowflake. We work with Accenture. We had a big partnership. And with Blue Yonder, we're driving Blue Yonder driving these solutions together. We basically embarked on a journey with Molam and his team on relational AI. So over to you, Molam.
All right, thanks, Aman. So as you heard from Aman, Blue Yonder is made up of a bunch of companies that were acquired over the years, and they have a portfolio of very sophisticated applications that have been developed by different teams and different technologies, et cetera. And last May, they announced to their customers that they're going to modernize all these applications by moving everything onto Snowflake as the platform for their intelligent or AI enterprise application suites. Okay? This is like, I think, at least dozens, maybe hundreds. The Blue Yonder team here can talk about that. So this is very exciting because Blue Yonder has always had a lot of credibility with the line of business executives around supply chain and around merchandising. But as this technology got long in the tooth, it started to become more of a liability with the CIO of the retailer and so on. And so the move to Snowflake as a platform was really a big move and created a lot of advantage because now Blue Yonder is not catching up, it's leapfrogging the competition because the competition isn't on what we believe to be the platform of the future, the data cloud, the Snowflake data cloud, okay? All right, but as you heard multiple times in multiple ways over the last couple of days, enterprise AI is different than consumer AI, okay? So that's sort of kind of getting rinsed and repeated into our heads here. And the reason that it's different is because your kind of data that you deal with is very often relational data, structured data, the kind of data that you find in SQL tables and so on. And because the focus of it is to improve decision making, right? A customer, a retailer, by the way, I can brag about Blue Yonder maybe more easily than Blue Yonder can brag about itself, like they're top right magic quadrant in a variety of categories in merchandising and in supply chain and so on. So basically the retailers and the CPGs and the manufacturers they work with have to allocate dollars to various things, to labor, to inventory, to raw material, to manufacturing capacity, to shipping, to logistics. They make investments, big financial investments in these things, and they have to be able to predict, whether these investments are going to pan out or not, okay? And so there's a lot of predictive analytics that has to happen on relational data sets that is very important. And there also, once you have a model that tells you what the demand's going to be or what the what the profit's going to be or whatever, you want to optimize and get sort of the best price or establish the best price or the best strategy or the best supply chain network, as Aman said, to kind of help you maximize profit. Okay? So in order to do that, you need everything Snowflake provides, you need everything that's in Cortex, but you also need support for a few other things. So relational AI is a coprocessor that plugs into Snowflake. And you heard about us a few times in the last couple of days. So we run inside SPCS. We're a native app. We're secure. It's basically, you can think of us as an extension of Snowflake, and we add support for these workloads here. I'm using a diagram from Gartner. Gartner calls this composite AI to kind of combine all the good stuff that Cortex does with generative models and other techniques, also with graph analytics. Because supply chain networks are graphs, so you need graph analytics to understand how things operate there. Logic and rules. There's a lot of stuff that there's workflow and other decision making that you want to make in like a regulatory environment, for example, that requires you to be symbolic and have symbolic AI. It's not some fuzzy thing. It has to be that you pay overtime after 40 hours a week, okay? That's not a suggestion, that's that's the law in many places. It has to include optimization. By optimization here, I mean mathematical optimization. I mean integer programming. I mean linear programming. I mean quadratic programming. I mean other types of mathematical optimization that is used to optimize supply chain networks. It also potentially includes simulation, because in the end, you end up building a digital twin of a supply chain network or a company, and you want to be able to simulate various scenarios, say, hey, I make this decision, what happens? I make this other decision, what happens? Okay, and then of course, classic machine learning in a variety of ways. And Blue Yonder has a lot of really cool capability there. And as we all know now, Gen AI and language models. Okay, so the idea is that you need these as building blocks to build AI into applications. Okay, intelligent applications aren't just a language interface to a boring old CRUD application, okay? You do hard stuff in an intelligent application. You're trying to make predictions, and you're using predictive and prescriptive analytics to maximize the return on billions of dollars being invested by a business, okay? All right, so we picked one. I think they picked a hard one. So this is an application that was seen as being particularly difficult to modernize because the people who worked on it no longer at I2. I don't know even if they're working. This is sort of, as Aman said, mid-90s code written in C++. I think even before Visual Studio, for those of you who remember that far back, and sort of the UI was developed using the Microsoft Foundation classes and so on. So not everybody's as old as me in the room, but that should take you way back, okay? And it looked like this, it had that cool Windows 95 user experience. It was desktop. It sort of could read and write data from Oracle, so you could sort of deploy it in client-server mode. It was 472,000 lines of C++, of which 205,000 lines were back-end business logic that would take data about a supply chain network from an Oracle database, take it out, pre-process it, do a whole bunch of arbitrary computation, feed it into a solver like Cplex, I think in this case, but there are other solvers, and then take the results and then do post-processing and then let the users decide whether this particular configuration of the supply chain network is one that's going to make them money or not. Okay? So there's a bunch of code in here that no one had a handle on. In fact, we got the code and we got an executable and we got user docs, but we couldn't make the code compile. So we had to sort of trust that the executable was there. And by the way, this is not unique to Blue Yonder. Like every large enterprise we work with has a ton of legacy applications developed in a variety of technologies by a variety of teams. Many team members no longer there. Okay, so this is a microcosm of a problem we see all over the place, and very important to think about that in the context of not just a software company, large software company like Blue Yonder, but also the enterprise, okay? And there was a competitor, emerging competitor in this space that was able to evolve their version of Supply Chain Strategist, and we wanted to kind of, take market share away from them. So we wanted to kind of map this to a knowledge graph so that we can make it sort of more dynamic, more easy to evolve and so on, okay? So I make the claim here that inside every application is a relational knowledge graph waiting to break out, okay? Because in the end, whether it's C++ or Java or C# or whatever you're writing your application logic in, you're typically creating classes of things that might represent a product or a distribution center or a warehouse or a supplier or a time of the year or a consumer or a customer, okay? And these are concepts that have corresponding sort of artifacts in relational databases. You might have a customer table and it's keyed by customer and you have a bunch of attributes of customer, or a supplier table, same thing, okay? So if you squint and you look at sort of a traditionally organized SQL database or a traditionally organized code base, you see basically a set of concepts, a set of entities, and relationships between them, okay? That's sort of at the core of what you want to be able to model. And here we're modeling supply chain networks, but we can be modeling different aspects of an enterprise. Okay, so a knowledge graph gives you sort of a very powerful way of modeling your domain of interest. In this case, supply chain networks. And the idea is we want to be able to sort of play around with different configurations of the supply chain networks and see what happens. Okay, so in this case, the 205,000 lines of C++ in their entirety, so the 205,000 lines of C++ that represent the back-end business logic, in their entirety, that's 20 pages of formulas, basically, okay? And so it's not often that I can take something that complex, okay, and sort of get past the for loops and the memory allocation and the parallelization and all the stuff people put in code that is completely accidental and has nothing to do with the problem you're trying to solve, okay? And just write a bunch of equations or formulas that, are surfacing the core knowledge, the core semantics that you have buried in the application, okay? And so this was pretty much the hardest part of this, is actually, it wasn't the coding it up, it's the figuring out what is the model that's hiding in this mess of code that we can surface and describe. Okay, and so this is the entirety of it in text and formulas. But you can also think of a knowledge graph. You can sort of visualize it diagrammatically. Here, we're looking at a model. I'm not going to teach you how to read this, but there's a facility. Facility can be of two types, a from facility and a to facility. There's a constraint that says you can't be a from and a to. You got to be one. And then there's a relationship, a four-way relationship that says, I don't know how to use the pointer here, but says, a from facility ships ships a product within a period to a to facility. Okay? Now the beautiful thing about these kinds of models as well is they're verbalizable, which means you can take a description of the knowledge graph and just verbalize it as text, and that becomes a great interface to pass into a prompt to a language model and say, hey, this is the world I'm talking about. I have facilities, I have periods, I have methods and sizes and weights and end dates and all of that kind of stuff. But instead of describing it sort of technically in code, you just describe it as if you're describing it to a colleague. Because you have the model, you have the underlying sort of conceptual model, the knowledge graph, okay? So this is, again, a different way of visualizing sort of the structure in an application. Okay, so what do we do? Basically, we would have a meeting every week with Aman and his colleagues, and every week we'd say, all right, here's the green part of the bar represented, here's how many of these output measures or output metrics that this thing computes that we've implemented. Basically, we've written the equations in a knowledge graph as relational queries. The blue part is the stuff that we were able to reverse engineer. We know we've written down the formula, but we haven't actually mapped it to the knowledge graph. And the yellow part is we have no idea how to compute this thing yet. We have to figure it out, okay? And then every week, over 15 weeks, we showed this progression towards more and more green, eventually no yellow, and less and less blue.
The beauty of this was 15 weeks. What he just casually said is the fastest modernization without having a single person supporting it, doing a total kind of a reversal of the code or understanding the code that existed without any documentation. And then putting it together and making it all green in 15 weeks. That was the beauty of it.
Yeah, so this was like an application that was deemed to be, it's going to take too much time, it's too expensive to move for a variety of reasons. And when you distill application logic to equation writing, the only thing you need to do is just capture the application logic, the business logic, okay? So that's the power of this sort of knowledge graph-based thing. Okay, and then as we went, we had Blue Yonder had a bunch of test data, and they would say, okay, run this test data through the old implementation, the legacy implementation, and run it through your implementation, and let's see what comes out, okay? And as time passed, we basically started showing that we were actually able to get the same exact numbers out of both systems for data sets that were pretty diverse. I have two slides here. We had small toy data sets like the potato chip model and so on, but then we had data sets that were actually coming from large retailers. We kind of scrubbed the names here because we don't want to talk about them, okay? And you can see the number of variables in the optimization is in the hundreds of thousands. And we're getting exactly the same answer, and in almost all cases, we were getting it faster than the C++ implementation that was calling out the Cplex. For a variety of reasons, because if you're writing relational business logic, in relational databases know how to automatically parallelize computation. We know how to make it sort of manage it if it gets bigger than memory. Databases do that stuff for you for free, but Java and C++ and C# don't. Okay, there's a bunch of stuff that you have to do by hand when you operate in that model. Okay, so this is extremely important for Blue Yonder because their gross margin depends on spending as little money as possible on cloud computing and all of that. Okay, so it's a big win, not just in wow, now we're in the game, we've modernized the thing, we don't have to carry all that legacy around. We're actually, our cost of running the solution in the cloud is much better. And I think we were either the first or second, we started this in September, October. And we were done in February, and we were able to demo it at ICON, which is the annual user conference, just a few weeks ago, validating that Blue Yonder moving to Snowflake is going to happen in months, not years. Okay, so very powerful. Okay, so you see, fairly extensively tested. Here's a little bit more in detail on the right-hand side. The table basically, we took the C++ code that we had, and we just counted it. Counted the lines in it, and basically categorized each module as this is business logic, this is GUI, this is utility, this is whatever. And if I can draw your attention to the first 3 rows to the table on the left, you can see the app logic was 136,000, the database and I/O logic 39,000, and the utility logic is 28,000. And that's all back-end code. That is the 205,000 lines of code I was telling you about. That was entirely replaced with 8,500 lines, roughly, of SQL and relational rules. Okay? So if you're a software company, your code base gets 20x smaller, what does that mean? It means a lot of good things. Okay? And if you're an enterprise with a bunch of legacy apps, what does that mean? Okay? So just to give you a flavor, on the right-hand side, you have the mathematical formulation. This is non-trivial, sophisticated business logic, because what we're optimizing for here is net present value of profit based on this particular configuration. There's a lot of IP, a lot of knowledge that Blue Yonder has around how to do this. But the idea, in the end, it sort of shows up as hey, I want to maximize network revenue, the sum over all periods of network revenue minus network cost minus the fixed cost. Okay, so what is network revenue? Well, network revenue is the discounted price times the served demand plus the sum of whatever shipments, okay? And then you take, well, what is that? And you just keep breaking it down into its components, and now you have a model of the supply chain. On the left-hand side is just in code, in a rule, in a relational rule, that just says the same thing. Okay, I can't read it here very well, but they define the objective as being equal to the sum of over FR, PM, et cetera, of the price times the direct shipment, minus the transportation costs and service costs, minus the variable and fixed production costs, minus variable and fixed inventory holding costs, and so on. Okay? And at the same time, you have ontology that tells you what our constraints must be satisfied. Like, you can't come up with something nonsensical in your supply chain. You can't have, I don't know, distribution centers in the middle of the ocean. Okay, that might be a constraint on the problem that you want to specify. Okay, and so you just write that down as if you just verbalize, hey, this can't be here, or I have to pay overtime after 40 hours, or whatever the constraints of the problem are. Like, the solution must satisfy these constraints because I can't break the law or whatever. Okay, and if you don't like to write equations like this, because some developers are very comfortable in Python and SQL and so on, we let you basically do the same thing by writing a little Python script that describes the equation. Okay? And a lot of the demos you saw over the last couple of days is basically using our Python library to identify or enumerate the core concepts in your knowledge graph and the relationships between them and the rules that apply and then that bind them. Okay? So what does that mean? That means now we have business people. We can actually surface these semantics to a business user, to a customer of Blue Yonder. They can actually look at that and say, oh, I know what you're doing here. I know what you're modeling. Actually, I don't like this assumption, or I think this constraint should be different, or whatever. Now we're bringing business people into the equation, and we're surfacing semantics, application logic, in a way that makes them very accessible. A lot of times, as we all know, business people, because they don't know what's going on, they copy the data out of the application, they put it in Excel, they roll their own, and good luck with the quality of that decision. I'm getting some chuckles down here. Okay, so why not make the semantics available for people to look at and understand the mappings from inputs to outputs at various places? Okay, they shouldn't be opaque, but because we've had to code them up in procedural imperative code, like a business person is not going to understand Java or C++ certainly, or C#. Okay, so understanding is much improved. You have a clear mapping of inputs to outputs, and you know what happens every step of the way. the ability to change it now. You can actually service business logic, and Aman talked a lot about the importance of sustainability. This application, remember, was written in the 90s. People didn't care about sustainability in the 90s, not as much. Now it's like a differentiating feature of a supply chain solution to reflect sustainability concerns. Okay, well, what does that mean? It means profit isn't the only objective. I want to maximize profit, but I want to do that in a sustainable way. I don't want to screw up the planet while doing it. Okay, so now you've modified the constraints and the objective function to reflect what sustainability priority. So you can do that. Blue Yonder can do that. The end user can do that. By capturing semantics this way, you get that benefit. Okay. We can also now, as people start to interact with semantics, sometimes people give you too many constraints, and there is no solution. So there's a bunch of stuff that happens on behalf of the user as part of our system. It says, okay, yeah, you can't have this and this and this apply. You got to pick something feasible. Okay, and we can detect things like numerical instability and things that will sort of make these types of problems a little trickier. Okay, so sort of to pull it together, our contribution as relational AI is we're a coprocessor to Snowflake. Again, hopefully you've been at the keynotes and you've seen us showcased in a variety of ways, where we help deliver on the promise of all data, all workloads, which has been a sort of the Snowflake promise, is, hey, we're the data cloud, you come here and we're the iPhone of infrastructure. AWS, Azure, GCP, they're like the IKEA of infrastructure. You have to hand assemble everything, right? Here, we have a platform, it's clean, you come in, you plug in, and all these services are available to you, including graph analytics, prescriptive analytics, rule-based reasoning, and predictive analytics, and so on. Okay? So that's how we plug in. Just a little plug about us. We basically run entirely in the Snowflake cloud. There's not a byte of data that leaves our system and goes outside of Snowflake. So if security matters to you, we have ironclad guarantees that your data is safe. As you create a knowledge graph in the context of Snowflake is just a new kind of table, and highly normalized relational tables that are just like dynamic tables in the sense they always stay in sync with the underlying data. So if you add a row into a Snowflake table, it shows up in the knowledge graph automatically. You don't have to worry about doing that, managing that. The alternative, of course, is if I want to do graphs today, I have to pick a point graph technology that is, like the Hadoop of that workload, okay, because it was developed on-premise, it was not cloud native, it sits outside of Snowflake, so you have to re-secure it, re-govern it, you have to move data out, you have to synchronize it. It's not even relational, so at the paradigm level, it's incompatible with Snowflake, okay? And so the alternative is very bad if you're a Snowflake user. Okay, because you just spent all this time and energy putting all your data in Snowflake so you can have all these advantages, and all of a sudden you have to, I have to do graph analytics, let me pull that data back out and take it somewhere else and redo all that work. Here, it's just like as if it was built into Snowflake, which is the beauty of the architecture of Snowflake. Okay? And you can go to our website, say get started. Right now it goes into Snowflake website, and we get an email that says you want to get started, and we can get you set. Okay? All right, let's do a quick demo.
We have 4 minutes left here, so we'll try to do a quick demo in 2 minutes. 2?
Go.
Here you go.
Yeah.
Okay, so this is how the user interface looks like now. What you're seeing on the graph is manufacturers, suppliers on the left, and demand regions. What we are doing is we are showing solver options. Say, okay, I want to solve it for maximizing my demand for now. Let me go solve it. It solves like in a matter of seconds. And objective function in this case could be, say, revenues or profits. Depending upon that, it comes up with the solution. And the solution could be acceptable or not. But now I could really play with scenarios. I could really say, okay, what if something drastic is going to happen? So there's a snowstorm coming in Salt Lake City, and that warehouse that I have over there is going to be shut down. So I'm not going to have any labor. So let's do that. Let's say turn it off because of this disruption. So we just go into the tool, you turn it off, and then you go and run the solver again, and it will re-optimize the entire network based upon the lack of availability of the Salt Lake City warehouse. And in this case, it might come up with the higher cost, but I'm going to say that I want to maximize the demand fulfillment for my customers. So even if it costs me a little bit more to route it from other options, let's do that. And it comes up with the scenarios. And the output, the user can see it side by side as to what the differences or key differences were between the cost of doing one versus the other when the other happens, or you can see it graphically side by side. So that's the power of the solution that we have been able to build together.
Yeah, awesome. So I think we're done here. I should have said when we talked about what we're doing. So you go to our website, as you heard Christian on Tuesday say that native apps and Snowpark Container Services are now in public preview or preview mode. So we have to track Snowflake that way. So for the graph analytics and the rule-based reasoning, we are also in public preview. We're still in private preview on the mathematical optimization, the prescriptive analytics, and the predictive analytics. So if you're interested in those things, you'll have to get in touch with us. And we'd love to work with you like we worked with Blue Yonder and like we worked with Cash App and AT&T and all the customers you've heard from at Summit so far. Okay, and with that, we don't need an executive summary. Again, obviously this is very Gen AI friendly and very important for Gen AI because the more context you can give the language models in terms of the domain, and the more you can give it in natural language, not C++ code or Java code, the better it's going to get it and the more you'll be able to work with Gen AI. And Gen AI goes from being able to just answer questions that you can answer in SQL, which are questions about what happened, to now being able to answer questions about what's going to happen and what should I do about it, the predictive and prescriptive analytics, and answer questions that require you to do graph analytics and so on to understand. All right, thank you. Open the floor for questions.
Thank you.